In this tutorial, we are going to build a real-time data pipeline that shows you how raw sensor data moves from generation to live dashboards, persistent storage, and smart alerts. It all starts with simulated IoT data created by a Python script. That data flows into Kafka, our streaming platform. Using Kafdrop, we can pick inside Kafka and verify that the data is flowing correctly. From there, the data is picked up by Telegraf, a lightweight agent that collects, processes, and routes metrics. Telegraf then splits the data into two paths. One goes to MongoDB for persistent, long-term storage. The other flows into InfluxDB, a time series database for real-time analysis. From InfluxDB, we'll create live dashboards in Grafana and set up automated alerts via Slack if anything goes wrong. Let's see how it all comes together. The first thing we need to do is to head over to my GitHub repository and download the project. It's called Kafka to Grafana pipeline. You'll find the link in the description below. Since this project runs entirely on Docker, the next step is to make sure Docker is installed and running on your machine. If you don't already have it, just head over to the official Docker website and download the version that matches your operating system. Let's open up the project in our IDE. I'm using Cursor, but feel free to use VS Code or any other code editor you prefer. Go to File, Open Folder and select the folder you downloaded and unzipped earlier. Once it's open, you'll see the main folder, Kafka to Grafana pipeline, which contains all the components we need for this build. There are a few key files you should get familiar with right away. The Docker Compose file. This is our launchpad. It sets up all the services and containers with just one command. Send temperature pressure sinusoidal. This script simulates the IoT sensor data will be streamed through the pipeline. Telegraf configuration file. This is where we configure how Telegraf reads from Kafka and writes to MongoDB and InfluxDB. Variables.env. This file holds all our environment variables, token, port, credentials, and more. We walk through this step by step, but for now, make sure the project is open and ready to go. Now, let's set up a Python environment where we'll install the necessary dependencies. Honestly, we only need one package to run this project. It's called Kafka Python. I like using Conda for this, since it makes managing environments super easy. Just open your terminal and run these commands: Conda create -n, the name of your environment and the Python version. Then activate the environment with Conda activate the name you have chosen. Finally, install the required packages using pip install -r requirements.txt. And that's it. Your environment is now ready to run the project. Now, let's build and run all the containers for our pipeline. In your IDE, locate the Docker Compose file. It's called Docker Compose. Right-click on the file and choose to open it in a terminal. You can choose your IDE's internal terminal or, like me, an external one. In the terminal, run this command exactly as shown. Hit Enter and Docker will start pulling the image and building each container. Open your Docker desktop app to watch the containers spin up in real time. Before we dive deeper into the technologies and how the pipeline actually works, we need to complete one last step, just to make sure we have some real data flowing through the system. So now let's run the script that simulates our IoT data. In your IDE, locate the file called send-temp-pressure sinusoidal.py. Open it in terminal. Next, activate the environment we created earlier. In my case, I called it Kafka Sender. So I'll run Conda activate Kafka Sender. Then run the script with Python 3, the name of the Python script. As soon as it starts, you'll see the terminal printing simulated temperature and pressure values. Since this tutorial is meant to be a high-level overview, I won't go deep into the theory behind each technology, but I do want to make sure you understand what tools we are using and what each one is doing, so the pipeline makes sense as we go. Let's start with the Docker Compose file. Inside it, we define all the services we'll use in this pipeline. That includes Zookeeper, which coordinates distributed systems, and in this case, it's used by Kafka. Kafka itself, our core message broker, Kafdrop, a web UI to inspect Kafka topics, InfluxDB, a time series database, Telegraf, which we'll talk about more in a second, Grafana for building visual dashboards, and finally MongoDB, which we'll use to store aggregated data. Each of these containers has its own image, container name, port, environment variables, and network settings. I won't go deep into the Docker syntax here, that's beyond the scope of this video, but if you are interested in a deep dive into how Docker Compose works, just let me know in the comments. I'll be happy to break it down in a separate video. Now let's talk about Telegraf, a lightweight, pluggable agent that collects and forwards metrics. In the Telegraf configuration file, we set a few core parameters, but the most important sections are output plugins, input plugins. In the output section, we are sending data to InfluxDB, and we are also using a built-in aggregator called Basic Stats. This plugin summarizes data before sending it to MongoDB, so we are not storing every raw reading, just useful aggregates to build a history. The input section defines how we consume data from Kafka. We connect to the broker, subscribing to two topics, temperature and pressure, and let Telegraf pull data from there. Another key file is variable.env. This holds all the environment variables for our services, including tokens and credentials for InfluxDB, Telegraf, and Grafana. And finally, we have the send temperature pressure sinusoidal.py script. This is the data generator. It creates a clean sinusoidal wave of temperature and pressure data so we can easily visualize patterns instead of a plain graph. Alright, with all this running in the background, we are ready to dive into how the data moves through each stage of the pipeline. Now, let's take a closer look of what's happening inside Kafka using Kafdrop, or Kafka web interface. Head over to your Docker desktop and locate the Kafdrop container. In the port column, you'll see a link pointing to localhost. Just click on that link and it will open the Kafdrop UI in your browser. Here, you'll see a list of topics, including pressure and temperature. Click on either one to inspect it. You'll see metadata like total size and total available messages. Try refreshing the page every few seconds, you'll notice the number increasing in real time. That's a good sign. It means our Python producer is actively generating data and Kafka is receiving it exactly as expected. As we said earlier, all data leaving Kafka flows into Telegraf, and Telegraf then routes that data into two different systems. The first one we'll explore is InfluxDB, which stores the time series data for analysis and visualization. To access it, go back to your Docker containers and look for the one exposing port 8086. That's InfluxDB. Click the link and it'll open a login page. Now your screen might look slightly different from mine. I'm already signed in, but the process is the same. If you are prompted with an onboarding screen, just enter the required fields: username, password, organization name, bucket name. You'll find everything you need in the project files. Inside the telegraf.conf, under the output plugin section, you'll see the organization name. We've just called it organization, and the bucket is system state. For the username and password, go to the variables file. There you'll see both listed as username and password. Enter those credentials, click sign in, and you'll be taken to the InfluxDB dashboard. On the left-hand panel, click the third icon. That opens the Data Explorer. In the middle of the screen, select the bucket we configured earlier. It should say System State. Then expand the measurements and you'll see one called Kafka metrics. Inside, under fields, you will find both temperature and pressure. Select them, then click the Submit button on the right. You should now see a graph showing the real-time data flowing through the system. And that means that our pipeline is working, from the Python script through Kafka into Telegraf and finally into InfluxDB. Everything is flowing as expected. We'll come back to InfluxDB later for a bonus step, setting up alerts via Slack. Now, there are other ways to trigger alerts, for example using Grafana, but for this tutorial we'll keep it simple and show you how to do it directly from InfluxDB. So that's InfluxDB in action. Simple, clean and super powerful for storing and querying real-time data. Now, let's move on and see how this data looks in Grafana, our visualization layer. Back in Docker Desktop, find the Grafana container and click the exposed link. You'll be taken to the login page. If your screen looks different from mine, that's totally fine. I've already signed in before. To log in, you'll need a username and password. You can find both inside the variable file. Once you are logged in, we are ready to connect InfluxDB as a data source. In the Grafana sidebar, go to Data Sources, add data source, then choose InfluxDB. On the setup screen, here's what you'll fill in. Query language, set this to Flux. URL, you'll find this in Telegraf. Under the Output plugin section, copy the value from the URL line. Disable basic auth, turn it off, we don't need for this tutorial. Now, under InfluxDB details, fill in the rest. Organization, token, copy this from telegraf.conf, it's listed as InfluxDB token. Bucket, use system state. Once everything is filled in, click Save and Test. If everything is working, you'll see a green pop-up saying that the data source is connected and buckets are found. That's your confirmation. Now let's build our first dashboard. Go to Dashboards, New Dashboard, Add Visualization. In the query editor at the bottom, make sure you select the correct data source, InfluxDB, choose the bucket system state, set the measurement to Kafka metrics, choose the field, let's start with pressure. Once that's set, refresh the dashboard. You'll see the data appear live on the graph. If you want, click Transparent Background to clean up the look. Give your visualization a title, for example, Pressure, then click Save Dashboard, enter a name like Control Room and hit Save. You'll be taken back to your dashboard. From here, you can add more panels, just click the Add button, choose Visualization and repeat the process. We have completed the full path, from the simulated data source all the way to a live dashboard in Grafana. Now, let's talk about saving data in persistent storage. As I mentioned earlier in this tutorial, we are using MongoDB as our main database to store aggregated statistics from the pipeline. To view this data, we'll use MongoDB Compass. Head over to the official MongoDB website and download Compass. Once it's installed, go ahead and open the application. On the left-hand side, click on Connections, then hit the plus button to create a new connection. You should see a default connection string that looks like MongoDB localhost 27017. That's exactly what we want. This matches the MongoDB port we configured in our Docker Compose and Telegraf setup. Give this connection a name. I called mine Aggregated Data and hit Save and Connect. Once connected, you'll see a few default databases, admin, config, local, and also one called System State Statistics. Click on that and inside you'll find a collection called Aggregated Data. Compass should automatically detect this is a time series collection, and when you open it, you'll see structured entries like pressure mean, pressure SU, and other statistical fields. So, let's quickly recap the full pipeline. We started with a Python script that simulates IoT data. That data is sent to Kafka. We inspect it using Kafdrop. From Kafka, it's picked up by Telegraf. Telegraf routes the raw metrics to InfluxDB and aggregate to MongoDB. We visualized live data in Grafana and finally stored and explored statistics in MongoDB Compacts. Now let's add a bonus feature to our pipeline, setting up alerts that get sent directly to Slack. Slack gives us a simple way to monitor key metrics in real time. You can use the desktop app or just work from the Slack web interface. I'm using the macOS app for this demo. Once Slack is open, go to the left-hand panel where your channels are listed. If you don't already have one, create a new channel for your alert. I've created one called Alerts. Now let's set up the Slack API webhook that connects to InfluxDB. Go to your browser and search for Slack API, then click Get Started. In your Slack dashboard, go to your app and click Create New App. Choose from scratch, give your app a name, for example, Control Room, and select the Slack workspace you want to use. I'll choose my own workspace for this. After creating the app, you'll land on the app dashboard. On the left side, scroll down to Incoming Webhooks and click on it. Enable Incoming Webhooks, then scroll to the bottom and click Add New Webhook to Workspace. Choose the Slack channel where alerts should appear, in this case alerts, and confirm. You'll see a success message and you'll be given a webhook URL. Copy that because we'll use it in a moment. Now let's head back to InfluxDB to finish the integration. Click the bell icon in the left sidebar, that's for alerts. Here we'll create three things: a check, a notification endpoint, and a notification rule. Start with the check. Choose threshold check, not deadman for now. On the next screen, select your bucket, system saved, your measurement, Kafka metrics, and the field you want to monitor. In this case, let's use pressure. As you fill in the options, InfluxDB will tell you which requirements are complete and which are missing. Go to Configure Checks and on the right, set a threshold. For this example, I set a CRIT alert if pressure drops below 100 or rises above 100.1, so we can immediately see the alerts on Slack. Give it a name like pressure check and hit save. Now go to the Notification Endpoints tab, create a new endpoint, select Slack as the type and paste the webhook URL from earlier. Give it a name like Slack endpoints and click Save. Last step, go to Notification Rule and create a rule that links your check to your Slack endpoint. Name it something like Pressure Alert Rule and save it. That's it. Now, when your metric crosses the threshold, Slack will automatically notify you in the selected channel. As soon as the condition is met, the alert will trigger and show up live in Slack. And that's how you add real-time alerts from InfluxDB to Slack. And that's it. We have officially built a full real-time data pipeline from scratch. We started by simulating IoT data with Python, streamed it through Kafka, inspected it with Kafdrop, processed it with Telegraf, stored it in MongoDB and InfluxDB, visualized it in Grafana, and finally added the live Slack alert for critical events. This stack is clean, scalable, and 100% open source. If you found this helpful, make sure to like the video, subscribe, and drop a comment if you have any questions or ideas for future builds. I'd love to hear how you're applying this in your own project or how you'd improve it. Thanks so much for watching, and I'll see you in the next one.